Ever feel like you're just drowning in information, like constantly trying to find the important stuff in just a sea of noise?
No, absolutely. It's a huge challenge for everyone these days.
It really is. But what if there was, I don't know, a smarter way, a kind of personalized shortcut to get you right to the core of what you need to know?
Well, that's pretty much what we're digging into today. Welcome to the deep dive. We take your sources, pull out the key knowledge, fast and efficiently.
Yeah.
And today we're diving into this really interesting project. They're building something called a powered content navigator, and it uses some pretty cutting edge AI.
Okay, powered content navigator. So the source material we have is what, a document, like a PDF detailing the project.
Exactly, a detailed PDF that outlines the whole development process, their findings, everything.
Gotcha. And our mission for this deep dive is basically to understand how they're using this AI, this generative AI or GenAI in like a clever, multi-layered way to tackle that big problem, information overload.
Precisely. And just to clarify, when we say generative AI, we're talking about AI systems that can actually create new content, not just analyze what's there.
Right, they generate stuff.
Yeah, like new text, images, code, audio, based on patterns they've learned from existing data.
And the specific AI driving the generation in this project.
They're using Google's Gemini models. These are really powerful, very capable models that can handle different types of input text, images, you name it, multimodal.
Okay, Gemini. And you mentioned something to manage the process.
Right, to orchestrate all the different AI steps, all the workflows, they used a framework called LangGraph.
LangGraph. Okay, so that's like the conductor for the AI orchestra, kind of.
That's a good way to put it, yeah. And for the user-facing side of things,
How would someone actually use this navigator?
they built the interface, what you actually see and interact with, using Streamlit.
Mm-hmm.
And to serve up the AI's capabilities, they used FastAPI to build the API underneath.
Right, the plumbing.
Exactly. But the core idea, like you said, is using AI to really hit that information overload pain point head on.
Okay, so let's get into the build. How do they actually start putting this content navigator together? What were the first steps?
Well, they started out really organized, which is always a good sign. They set up a very clear directory structure right from the beginning.
Makes sense.
Separate folders for the Streamlit app code, for the different types of content like PDFs, YouTube stuff, and for the databases.
Databases, plural.
Yeah, they used ChromaDB, that's a vector database, good for understanding text meaning,
Yeah.
and also a standard SQL database.
Okay, vector and relational. Got it. And managing keys and things.
They used Google Colab user data for handling API keys securely. Smart move.
Definitely.
Yeah.
And the core tech, the libraries.
Oh, quite a list of Python libraries. Things like Selenium for web browsing automation,
Uh-huh.
WebDriver Manager to handle the Selenium setup, LangGraph and LangChain for the AI workflows, PyTube and YouTube Transcript API for dealing with YouTube content, Google Gemini library to talk to the Gemini models, Chromab for that vector database, networks probably for graph analysis or visualization, Streamlit for the UI, PyPDF2 for PDFs, FASS, another vector store option, and even MovieP and Imagio for video processing later on.
Wow, that's a serious toolkit. It really touches on a lot of different areas.
It does, and they also created a requirements.txt file.
Standard practice, yeah, to make it reproducible.
Exactly. Locks down all those dependencies.
So the document mentions this tools.py file. What's its role in all this?
Ah, right. Think of tools.py as the toolbox for the main AI brain for Gemini. It's where they define all the specific capabilities the LLM can actually use.
So it's not just the raw model. It's the model plus these specific actions it can take.
Precisely. Things like browsing a website, summarizing text, interacting with the SQL database, pulling YouTube transcripts, all those functions are defined as tools in this file.
Okay, and what kind of libraries are inside that file, giving it these powers?
A whole bunch, again, showing the range. You've got pathlib for file paths, time for pausing, Selenium, WebDriver Manager, urlib for web stuff, BS4, that's beautiful soup for parsing HTML.
Right, for making sense of web pages.
Yeah. IPython.display for showing things nicely, requests for making web calls, pandas for data tables, re for text patterns, google.geni, of course, LangChain core.tools, Sqlik3 for the SQL database, JSON for data structures.
Keep going.
YouTube Transcriptify, OS for system interaction, TextWrap, Google.colab.userdata for the key, Pydantic for data validation, PyTube, And importantly, the LangGraph tools for defining the workflow agents and tools.
It really sounds like it's equipped to handle almost anything thrown at it.
Okay.
And how does it actually get configured to use these tools?
All right, yeah.
Connecting to the AI.
Good question. There's a configuration section in there. That's where they securely get the Google API key using that user data feature.
Okay.
And they explicitly set the model name they want to use, Gemini 2.0 Flash in this case. Probably chosen for its speed.
Makes sense for interactive stuff.
And they define those base path variables. Those are just shortcuts, like telling the tools exactly where to find the PDF folder, the YouTube folder, the database files, and so on. Clear signposting for the AI.
Got it. Everything organized. Okay, let's move to the first big feature, summarizing web pages. How does the navigator handle that?
Right, so the first page in the Streamlit app is dedicated to this. You give it a URL, and it goes off, grabs the content, and gives you a summary.
And how does it go off and grab the content? What's the tech behind that?
That's where Selenium comes in again. It basically drives a web browser behind the scenes to load the page. Then Beautiful Soup, BS4, steps in to parse the raw HTML code of the page, pulling out the actual text and structure in a way that's easier for the AI to work with.
So it cleans it up first. And how does it manage the state, the information it needs while it's doing the summary?
They use a Python feature called typict to define something called web summary state. It's like a structured container. It holds the URL the user entered, maybe some optional info from a CSV file, the summaries it generates both text and JSON versions, and those token counts we talked about.
Ah, yes, tracking the token usage. Always important for cost and efficiency. So what's the core function doing the summarizing work?
That would be generate summary web page. This function takes that web summary state and uses the Google GenAI SDK to talk to Gemini.
Right.
And critically, the AI doesn't browse directly. It uses a tool called BrowserL, one of those tools defined in tools.py, to fetch the actual web page text.
So it delegates the browsing task. Smart. What kind of instructions does Gemini get for this?
It gets system instructions, like a little mission briefing, tells the AI, you have this BrowserL tool. Your job is to use it to get the content from the user's link and then summarize it.
Pretty clear goal. And the actual call to the model.
They use client.models.generate content from the SDK, specifying that Gemini 2.0 Flash model. The response, which is the summary in JSON format, gets saved to a file.
And they track the tokens for that specific call.
Yep, both input tokens, how much text went in, and output tokens, how much text came out of the summary. Very meticulous.
Good MLOps practice. Okay, so how does a user actually use this feature in the app? What's the interface like?
It's all in the Streamlit sidebar. Pretty neat. You get a few pre-filled example URLs, like a Kaggle guide, a GitHub page, so you can try it quickly.
Oh, nice.
Or you can just paste in any URL you want. There's also an option to upload a CSV file, which seems like it provides maybe specific fields or context to guide the summary.
Interesting. So you can guide it a bit. How do you start the process?
There's a big button, Generate JSON Summary. You click that, a spinner shows it's working. And behind the scenes, that kicks off the LangGraph workflow, which manages fetching the page, sending it to Gemini, getting the summary back, and handling the state.
LangGraph running the show again. And the output. What does the user see?
The app displays the generated JSON summary directly on the page, and it gives you download buttons, one for the JSON summary and one for a CSV summary if you provided that input CSV.
So you get the structured data and maybe a spreadsheet view. The document had an example of that CSV output, didn't it? For a Kaggle link.
It did, yeah. It showed columns like linked, the actual URL and link value, a link key indicating what kind of link it is, like Kaggle exercise or YouTube video, and then a really useful link summary column.
What was in that summary column?
Short descriptions of each linked resource, like day 1 live stream recording for a YouTube link, or day 1 prompting fundamentals code lab for a Kaggle exercise link. A quick glance tells you what's what.
That's super helpful for navigating related resources. And there was another example too, right? For a GenAI course.
Yes, and that one showed the versatility. Instead of just code labs, it listed links to podcast episodes and white papers related to the course. Again, the link summary gave you the gist, like the podcast title, or a description of the white paper's content. Shows it can handle different kinds of linked web content.
Very cool. So first step is grabbing web content, summarizing it, and even summarizing the links on the page. What's next? Page 2 seems to be about an interactive database chatbot.
That's right. So you've got all this summarized data. The next logical problem is, how do you let people easily ask questions about it? without having to manually sift through JSON files or
Yeah,
spreadsheets.
you want to talk to it naturally. How did they build that?
They used FastAPI to create the backend API for the chatbot. FastAPI is really popular for building APIs with Python quickly.
Oh, yeah.
That API is what the Streamlit frontend talks to, sending your questions and getting the answers back.
Fast BI handling the communication. And how does it manage the conversation flow? Is there another state object?
Yep, similar pattern. They defined an InteractDB state, again using typebict. It keeps track of your latest question, the whole message history, a flag to see if the chat should end, and of course, the token counts for the interaction.
Tracking state and tokens again. And the core function talking to the database.
That's Interact with DB. This is where Gemini, guided by the system, uses tools, presumably SQL tools defined in tools.py, to query that SQL database holding the summarized website info.
So Gemini translates natural language questions into SQL queries.
Essentially, yes. It figures out what the user is asking, formulates the right SQL query using its tools, gets the results back from the database, and then formulates a natural language answer based on those results.
Clever. The document also mentioned a retry policy. Why add that?
Yeah. Sometimes API calls to AI models can fail for temporary reasons, network glitches, the service being busy. A retry policy, which they implemented using some Google client libraries, automatically tries the request again a few times if it fails initially, makes the chatbot more robust and less likely to just error out on you.
Building in resilience. Good thinking. What kind of instructions does the AI get for this database interaction task?
They're pretty specific. It's told it's a chatbot interacting with a SQL database containing web page data. It knows it can use tools to query the database. The instructions guide it, take the user's question, translate it into SQL, execute the query using the tool, get the data, and then answer the user based only on that retrieved data. It's also told how to potentially handle inserting new data if instructed.
So it's grounded in the database content
Yeah.
and maybe can learn.
Uh-huh.
Interesting. How does LangGraph handle the back and forth conversational turns?
They set up a LangGraph graph for this too. It has a main node, interact with DB, which runs that core function. Then there's a conditional edge, like a decision point, called maybe exit human node.
What does that do?
It checks if the conversation should end, probably based on user input like typing exit. If not, it loops back to the interact with DB node, allowing the conversation to continue.
A simple but effective conversational loop. And the FastAPI app we mentioned, how does it plug into this LangGraph process?
The FastAPI app defines the web endpoint, the specific URL that the Streamlit frontend sends requests to. It's a POST endpoint at generate. When Streamlit sends the user's question to generate, the FastAPI backend receives it, likely packages it up with the conversation history from the interactive state, and then invokes that LangGraph graph to get the AI's response.
Got it. And how does the response get back to the user smoothly? Does it wait for the whole answer?
No, and that's key for a good chat experience. It uses server-sent events, or SSE.
Streaming.
Exactly. As Gemini generates the response token by token, the FastAPI server streams those tokens back to the Streamlit app immediately. So the answer appears gradually in the chat window, feeling much more interactive and less like you're waiting for a big block of text.
Yeah, that makes a huge difference to the feel. What does the chat interface look like in Streamlit?
Pretty standard chat UI. Title, some brief instructions, and a text input box at the bottom for your questions.
Familiar.
Your messages and the assistant's streamed responses appear in the main chat area, scrolling like any typical messaging app. Straightforward and effective.
Nice. Okay, so we've got web summaries and a database chatbot. The next sections seem to broaden the scope quite a bit. Q&A over documents and YouTube videos.
Right. This is where they really start leveraging vector databases more heavily. Pages 3 to 5, or maybe separate apps, focus on letting you chat with uploaded PDFs, YouTube video content, even HTML pages you provide.
Expanding the knowledge base. What are the key technologies enabling this? You mentioned vector databases.
Yeah, ChromaDB and ASAIs are central here. They take the text from PDFs, YouTube transcripts, etc., and convert it into vector embeddings numerical representations. This allows for similarity search. The system can find documents or video segments relevant to your question based on semantic meaning, not just exact keyword matches.
Understanding the concepts. How does it get all that content, PDFs, videos, web pages, ready for these databases?
It's a multi-step process. Downloading PDFs is straightforward. For YouTube, they use tools to get the video transcript. For web pages, there's that can crawl URL function, again, to check robots.txt first, making sure they're allowed to scrape it.
Respecting site rules. Good.
They also have a function specifically for downloading files from Google Drive, which could be handy.
Okay, so they gather the raw content. But how do they extract useful Q&A pairs from something like a long YouTube transcript? That seems tricky.
Ah, that's where the extract from file function comes in. It's pretty clever. It uses Gemini, but with a specific structured output schema,
Hmm.
meaning they tell Gemini exactly how they want the output formatted. They provide a prompt instructing Gemini to read the text, like a transcript, identify distinct questions and their answers, summarize the core point of each answer, ignore irrelevant stuff, and format the result as a numbered list of Q&A pairs in JSON format.
So they're using the LLM itself to structure the knowledge from the content.
Exactly. They even show the prompt they use. It's quite detailed, guiding the AI precisely.
And for YouTube specifically.
There's the get YouTube transcript function. It fetches the transcript using the API, saves it, and then immediately calls that extract from file function on the transcript to pull out and save the Q&A pairs separately.
Automating the whole pipeline from video to structured Q&A. What about those links found earlier in the web page summaries? Do they feed into this?
Yes, it looks like they processed those too. If a link was tagged as a white paper, they download it as a PDF. If it was a YouTube link, they run that get YouTube transcript process on it to get the transcript and the Q&A.
Connecting the dots. Okay, now all this processed text, PDF, task, transcripts, Q&A pairs, how does it actually get into ChromaDB?
There's a process described for getting documents from directories into the vector database. It involves initializing the ChromaDB client and then adding the data from the saved JSON files, the PDF content, the YT transcripts, the YT Q&A.
Loading it all up.
Yeah, the example shows they loaded like 22 PDF documents, 34 transcript documents, and 34 sets of Q&A pairs into different ChromaDB collections.
Building up specific searchable collections. The doc showed an example of the extracted Q&A JSON, right?
It did. It included Q&A pairs on AI concepts like SFT, supervised fine-tuning, RLHF, reinforcement learning from human feedback, and REG, retrieval augmented generation. Gives you a sense of the specific knowledge nuggets it's capturing.
Key AI terms. So how does the chatbot use these vector stores to answer questions?
They bring in LangChain's retrieval queue with source chain. This is a really powerful component.
How does it work?
It takes your question, uses a retriever connected to ChromaDB or FAIS to find the most relevant text chunks from the index documents or Q&A pairs. Then it bundles your question in those retrieved chunks and sends them all to the LLM chat Google Generative AI with that Gemini 2.0 Flash XB model again.
Okay, so the LLM gets context.
Exactly. The LLM uses that context to generate an answer, and the with sources part means it can often tell you which document or video segment the information came from. Very useful for verification.
Yeah, citing sources is crucial. But it sounds like they went even further, creating different AI agent roles. What's that about?
This is where it gets really interesting. Using LangGraph for more complex workflows, they defined multiple specialized AI agents, a researcher, an editor, a simplifier, a mind map agent, a video agent, and a face retriever.
A whole team. Okay, let's break that down. The researcher.
The researcher's job is to find the relevant information. It has tools to query the different vector stores, interact with ChromaDB EDF, T for YouTube transcripts, Col for the extracted Q&A. It digs through the PDFs, transcripts, and Q&A based on your query.
So it gathers the raw intel. What about the editor?
The editor takes the researcher's findings and synthesizes them into a structured report. It organizes the information, maybe compares different points, summarizes the key findings, adds a conclusion, and cites the sources the researcher found.
Bringing structure and coherence. And the simplifier and mind map agents.
The simplifier does what the name suggests. Takes complex technical output from the researcher or editor and rewrites it in simple, easy-to-understand language. The mind map agent aims to generate visual diagrams, maybe using something like mermaid syntax, to represent the information visually.
Making it more accessible. What does the video agent do?
The video agent's role is to create scripts for educational videos based on the research. It can even use Google search as a tool to pull in extra info if needed for the script. It seems designed to generate structured scripts, potentially including visual descriptions.
Laying the groundwork for video content. And there was another retriever. Face retriever.
Yeah, it seems similar to the researcher, but specifically designed to use face as its vector store instead of, or in addition to, ChromaDB, maybe for comparison or different use cases.
Options. So how do all these agents work together? Who manages them?
That's the job of the supervisor workflow, also built with LangGraph. The supervisor acts as the coordinator. It takes the user's initial query and decides which agents need to run in what order. It passes information between them, like sending the researcher's findings to the editor.
The conductor for the agent orchestra. The document had an example query about prompt engineering, right? What did that produce?
Yeah, the results were pretty comprehensive. That one query triggered the supervisor to coordinate the agents, and they produced a detailed research report, a simplified explanation, and a video script all about prompt engineering.
All from one question. What was in the research report?
It followed a nice structure: introduction to prompt engineering, methodology, explaining techniques, comparison with other methods, a detailed research summary, conclusion, and sources. Really covered the topic well.
Thorough. How did the simplifier explain GenAI?
It used a simple analogy comparing GenAI to a robot learning from stories to write its own news story. Very basic language, short sentences, easy to grasp if you're new to it.
Accessible. And the video script.
Yeah.
What was that like?
It was a script for a beginner's guide, maybe 5 minutes long. It covered the what, why, basic elements of prompting, gave real-world examples like for emails or image generation, offered tips, and had an encouraging conclusion. Well-structured for a video format.
Sounds like a solid intro video. Did it mention generating more technical scripts too, with structure?
Yes, it detailed generating a more technical script, and crucially, using a structured JSON output for each video segment.
How was that structured?
Each segment had fields like image prompt, describing the visual, audio text, the narration, and character description. This structure makes it much easier to automate the next step, actually creating the video assets.
A blueprint for generation.
Yeah.
Okay, the document then talks about interactive Q&A and video generation
Okay.
specifically for educational reinforcement. Sounds like closing the learning loop.
Exactly. It's about making it an active learning tool. They built an interactive quiz feature, pulling questions from those extracted Q&A pairs in ChromaDB. You take the quiz, and Gemini acts as an evaluator, scoring your answers against the correct ones. LangGraph manages this quiz flow.
An AI tutor, almost. How does it use the results?
Based on your performance, it identifies topics you struggled with. It can even adapt the quiz, asking more questions on your weak spots. And then comes the personalized feedback.
The video feedback.
Right. If you got questions wrong, it takes those topics, finds relevant info using the vector stores, and then uses an AI agent, maybe the video agent or just Gemini directly, to generate a short video script specifically explaining those concepts you missed.
Wow. Targeted remediation.
Yeah.
What was the example they showed?
A user took a quiz on fine-tuning, got questions on SFT versus RLHF and RLHF steps wrong, scoring poorly.
Okay.
Because they opted to continue learning, the system flagged fine-tuning techniques as a weak area and generated a 10-minute video script summarizing those techniques, focusing on SFT and RLHF, tailored to the user's mistakes.
That's really personalized. Did it suggest visuals too?
Yes, it used Gemini to generate visual prompts for the script, like diagrams for SFT, animations for RLHF, showing improvement from feedback, icons for data efficiency, etc. Really thinking about the final video product.
Adding that visual layer. So the final piece, turning these scripts into actual videos.
That's the culmination. Taking the generated scripts, using Imagen, Google's image generation AI, to create the visuals based on those image prompt descriptions, using the Gemini Live API for realistic audio narration of the audio text, and then using MoviePy, a Python library, to stitch the generative images and audio together into a video file.
An end-to-end AI-powered video creation pipeline. Did they compare different ways of getting the info for the videos, like FESS versus ChromaDB retrieval?
They did. They noted that using face retrieval combined with that supervisor agent workflow seemed to produce particularly good educational video content. It highlights that the quality of the information retrieved to feed the script generation is critical for the final video's effectiveness.
Right, garbage in, garbage out applies even with fancy AI video generation. Okay, let's shift focus slightly. The document dives into MLOps practicalities, specifically token analysis and optimization. Why is that so important here?
Because using these powerful GenAI models isn't free. They consume tokens, basically units of text or computation, and that translates to cost and affects performance speed. Tracking token usage across the different parts of this complex system is crucial for making it practical and affordable to run. It's core MLOps.
Managing the AI fuel, what did their token analysis show?
They provided a detailed breakdown, token counts for generate summary web page, generate summary links, interact with BB, the chatbot supervisor, the quiz functions, ask question, evaluate answer, provide feedback, the video feedback generation, and even image generation.
Wow.
For each, they looked at input tokens, output tokens, and how many times each function was called. a proper audit.
Very thorough.
Yeah.
And based on that, what were their suggestions for optimizing for reducing token count?
They had specific ideas for each high-usage area. For web page summaries, where input prompts can be huge if the page is long, they suggested techniques like pruning the HTML first, maybe getting a shorter summary initially, and expanding later if needed.
Okay.
For summarizing many links, limit the number per request or focus the prompt on specific themes.
Makes sense. What about the more complex agent workflows and retrieval?
Optimize the retrieval step tune face ChromaDB parameters to return fewer, more relevant chunks. Use contextual compression to shrink the retrieved context before sending it to the LLM. Make the prompts to the agents more concise.
Streamlining the input.
Yeah. For the quiz, refine question phrasing, condense evaluation criteria. For video feedback, maybe only include key transcript segments, break down requests. Even for images, use more precise prompts and negative prompts to avoid wasted generation.
Lots of targeted optimizations possible. It's a continuous process, right?
Absolutely. And they wisely noted you have to test any optimization to make sure it doesn't hurt the quality of the output. It's a trade-off.
Right. The document wraps up with limitations in future scope. What challenges did they acknowledge?
The usual suspects for current GenAI, really. Accuracy issues, the potential for hallucination,
Fellow risk.
cost and latency of the models, the quality of AI-generated video still needs improvement, and ensuring the robustness and fairness of AI-based evaluation is an ongoing challenge.
Valid points. And where could this project go next? What's the future potential?
Lots of ideas. Enhancing the multimodality, maybe analyzing video directly, not just transcripts. Fine-tuning the model specifically for tasks like summarization or evaluation in this domain. Better MLOps integration for monitoring and management. Using context caching to make conversations more efficient. More sophisticated agent collaboration strategies. And of course, deploying it on scalable cloud platforms.
Plenty of room to grow. So bringing it all together, what's the big takeaway from this deep dive into the Powered Content Navigator?
I think it's a fantastic demonstration of a really integrated approach. It shows how you can combine multiple cutting-edge GenAI techniques, summarization, RAG, agentic workflows, video generation, into a single cohesive system aimed squarely at that huge problem of information overload.
Yeah, it's not just one trick. It's a whole suite of tools working together.
Yeah.
And the attention to practical MLOps details like token optimization really grounds it.
Exactly. It shows the path from cool AI demos to potentially practical, sustainable applications. This deep dive gives us a real sense of how personalized knowledge acquisition tools could evolve, making learning and information management much more efficient and engaging.
It definitely does. It really gets you thinking. What other aspects of information overload could we tackle with tools like this?
Yeah.
And what new questions does that raise? Lots to ponder.
Well, thanks for breaking all that down. That was a fascinating look at this project.
My pleasure. Always interesting to see how these technologies are being applied in new ways.